Okay, here we go to part 2 of our lesson today, and we're solving inequalities. And so that got me to wondering, why do you think the equal sign is so humble? Is it because he knows he's not greater than or equal to anyone else? Okay, so let's go ahead and solve this quadratic inequality. And the tricky thing is here, it's not just about dividing by a negative and switch the sign and everything else is fine. There could be multiple intervals of correct answers and multiple intervals of answers that don't work. And so here's the process. It's called the critical point method. The first thing we do before figuring out if the inequality is less than or equal to 0, or in some other problems, greater than or equal to 0, the first thing we do is just see where it equals 0. So step number 1, set it equal to 0. So we have x squared minus 2x minus 15 equals 0. If you can factor it, and solve for what we call the critical points, or the critical numbers. Solve for critical numbers. So let's see, this would factor into x minus 5 times x plus 3. And then we set each of those equal to 0. So we get x equals 5 or x equals negative 3. So these are known as the critical points or the critical numbers. Okay, so what happens is those are the places that make this thing equal to 0. This thing equals 0. We also need to know where is it less than 0. So what we're going to do is take our entire number line that goes from negative infinity to infinity, and we're going to separate it into intervals. So separate number line into intervals, and the places we separate it is where we have our critical points. So separate it with a critical point at negative 3 and at 5. So that means our intervals are going to be negative infinity to negative 3, negative 3 to 5, and 5 to infinity. Now what we want to do is figure out for each of these intervals, do we get something that is less than 0, or do we get something that's greater than 0? So do we get something that's negative, or do we get something that's positive? So what we have to do is we have to test, I'm going to write it down here, test a number from each interval. Where do we test it? We test it into the factors. We have a factor of x minus 5 and we have a factor of x plus 3 to see if it comes out positive or negative. So let me show you. I'm going to pick a number in the first interval. Let's say I pick x equals negative 4. Anything you want that falls between the endpoints. I take negative 4, I put it in here, negative 4 minus 5 is negative. All I care about is that it's negative. And then I put it in here, negative 4 plus 3 is negative. All I care about is that it's negative. Negative times negative is positive. Now I take a number from the next interval. Let's say I take x equals 0. That's my test number. So I'm going to put it in here. 0 minus 5 is negative. And then I'm going to put it in here. 0 plus 3 is positive. And a negative times a positive is negative. And then one more time, I'm going to test a number in the next interval. Let's say I pick 6. So I'm going to take 6 and I'm going to put it in here. 6 minus 5 is positive. And take 6 and put it in here. 6 plus 3 is positive. Positive times positive is positive. So once we have done the test, we draw conclusions. Analyze the test and draw conclusions. So going back to the problem. We wanted to know where is this less than or equal to 0. Less than 0 would be negative. So between negative 3 and 5. Where is it equal to 0? It's equal to 0 at the critical points. So we want to include the endpoints. So we're going to put square brackets. So that means our answer is x is an element of the interval, the closed interval, from -3 to 5. And that's the answer to the problem. We're going to do another one. We need a little bit of practice with this. So here's the next one. 3x squared minus 11x minus 4 is greater than 0. Okay, critical point method. Step 1, set it equal to 0. 3x squared minus 11x minus 4 equals 0. Step 2, solve for the critical points. Now I'm hoping that this is factorable, but if it's not factorable, you have to use the quadratic formula, and it just raises the level of difficulty of the problem, but the concept is the same. I think we're going to factor this one into 3x plus 1 and x minus 4, and that should work out. And so then we set each of those equal to 0 and solve each one. Oops, I forgot to do a step there, didn't I? 3x equals -1, x equals -1/3, and then over here we have x equals 4. Okay, so those are the critical points. So remember, now we make the number line, and then we make the intervals. So the number line goes from -infinity to infinity. We have a break at -1/3, and we have a break at 4. So the intervals are -infinity to -1/3, -1/3 to 4, and 4 to infinity. Okay, so now we're going to test the numbers, and then we're going to analyze and draw conclusions. So let's pick a number in the first interval. Let's say we pick x equals -1. Let's say in the second interval we pick 0. And let's say in the third interval we pick 5. So where are we testing it? We're testing it into the factors. That's the easiest place to do it. So -1 times 3 plus 1 is negative. -1 minus 4 is negative. Negative times negative is positive. Now let's try 0. 3 times 0 plus 1 is positive. 0 minus 4 is negative. Positive times negative is negative. Now let's try 5. 3 times 5 plus 1 is positive. 5 minus 4 is positive. Positive times positive is positive. Okay, what are we looking for this time? We want greater than 0. Greater than 0 means positive, so we want the positives. So we actually have two intervals. And notice it does not say equal to, so we don't want the endpoints this time. So our answer is x is an element of the open interval from -infinity to -1/3 union, remember union means or, the open interval from 4 to infinity. Okay. Now the next one looks different because we don't have a 0 here. This has to be a 0 in order to use this method. So, no worries. Let's subtract 12 from both sides. X times x plus 1 minus 12 is less than 0. Now let's simplify the left side. X squared plus x minus 12 is less than 0. And then factor. X minus 3 times x plus 4 is less than 0. Okay, here's what I'm going to do. I'm going to stop recording. I'm going to solve, and then I'm going to turn my recorder back on so you'll just see the solution. So that way, if you want to use this one for practice, you can press pause, you can solve on your own, and then you can resume and see if you did it right. Okay, so here we go. So we set it equal to 0. We set each factor equal to 0 and solve for the critical points. We split the number line into intervals at those critical points, pick a test number, and then test into the factors, get our signs, and then for this problem, because it said less than 0, we're going for the negative, so x is in the interval from -4 to 3. Okay, finally we have this problem and we're going to use a graphing calculator. It says if an object is launched from ground level with an initial velocity of 144 feet per second, its height in feet t seconds after launching is s feet, where s is negative 16t squared plus 144t. So s is the height of the object. When will the object be greater than 128 feet above ground level? So we want the height to be greater than 128. So there's our inequality. So here's how we can use a graphing calculator to do this. We can put our left side of the inequality into y1 and graph it. We can put the right side of the inequality into y2 and graph it. That's going to be a horizontal line. That one's going to be a parabola. And then we're looking for where the parabola is above, because of greater than, where the parabola is above the line. So I'm going to grab my calculator and show you. And we're going to be looking for the times, because it says when. So we're going to be looking for the x coordinate. Okay, so here you see my graphing calculator, and let me show you how to clear the memory just in case your calculator has some weird settings right now. So you press second, and then you press plus to get into the memory menu. You go to number 7, which is reset, and then you can reset all RAM, and then press number 2, reset. So that clears things out and it resets the defaults. So now we're going to press y equals, and we're typing negative 16x squared, you use an x instead of a t, plus 144x. Make sure to use the negative sign that's next to the enter and not the minus sign that's above the plus. And then in y2 we're typing 128, and we need to set some good window dimensions for this. So for the window, the x value is time, so I'm assuming we're not going into negative times here. I'm just going to do negative 1 to 10 and see how I like it. And then for the y values, we're talking about the height. So I'm going to do negative 10 to 160 and go by tens. And if we don't like those numbers, we can adjust them. Let's press graph and see what we get. Okay, you can see that I didn't make my y values go high enough to see the top of the parabola, but that's not really important in order to answer the question. We do see a line at a height of 128. So I just, let's see. Oh, that's my x value, not my y value, sorry. Let me clear that. So when x equals 2, when x equals 1, we happen to be right there at a height of 128. Now I don't really want to just guess at those numbers, so what we would do is to find the intersection point, we would go into the calculate menu, which is second, trace, and then we choose number 5, intersect, and then we put the cursor on the first curve and press enter, put the cursor on the second curve and press enter, and then move the cursor over closer to the intersection point and press enter. And you see at the bottom of the screen, you have the intersection point, 1, 128. So at time 1 is when the object starts to be greater than 128 feet. Now we need to find the other intersection point, so I'm going to go into the calculate menu again, second, trace, choose intersect again, and then once again, the cursor needs to be on the first curve, press enter, cursor on the second curve, press enter, and then move your cursor over closer to the other point of intersection. You can type in a number or you can just move it with the right and left arrows. It doesn't have to be right on it, it just has to be closer to it than it is to the other one. Press enter, and this intersection point is at 8, x equals 8. And the y value is 128. So our conclusion would be that between 1 second and 8 seconds is when the object is greater than 128 feet above the ground. And so in an interval, I would have 1 to 8 like this. We didn't have to approximate this time, but for some problems you're not going to get nice numbers like 1 and 8, and you'll just have to round those numbers when you're using technology to solve. The technology is great, but it doesn't necessarily always give you an exact answer. Okay, that wraps up our lesson, and here's our assignment. A couple of the problems have video tutorials available. Thank you, everyone.